Alright guys, welcome to PreCalculus 1.3.2. So today we're going to be going more into unit circles and radians. So ideally, if you can get yourself a circle of paper, the size doesn't matter, but make it not like tiny so that you can actually fold this a few times. That's what we're going to be kind of working with today to kind of help us kind of explore and see kind of how these radians work. So I'm going to change my view to this. Actually, I might show you this next slide first. Right, so basically we're going to be trying to make these angles here. We're going to be trying to get 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, all the way up to 2 pi. Okay. So what I have, the full circle right now is 360 degrees, or in radians, it's 2 pi, right? So it's currently 2 pi. If I fold it in half, I've now taken that 2 pi, and now the angle that I'm showing is 1 pi. Just there to there, it's a 1 pi. Right? So I have that now. So make sure you decrease it pretty well. And then if I fold it again in half, I'm now at 1/4 pi, or pi over 4. Right? This is a quarter of the circle, so it's a quarter of the circle, so it's pi over 2. Sorry, not pi over 4. So pi over 2, right? So we go from 2 pi to pi over 2. Right? So then if I want to, hey, how about pi over 4? Well, we'll fold that in half again. Right? So now there's my pi over 4. So if I unfold this entirely as it is, I should have quite a few angles now be visible in the creases. Okay, so we're going to have, if this is my 0, because this is the positive x-axis if this is my origin, right? Here is pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, all so it was just plain old pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2 on the bottom, 7 pi over 4, and then 8 pi over 4, which is also known as 2 pi. So that's my circle there. So that gives me a good amount of what I'm actually looking for here, right? But I'm missing some things, right? I'm missing my thirds and my sixths, because I have my fourths, my halves, but I really don't have my sixths and such. So let's actually go back to this and let's see how we can actually get those. So here's pi. Here's pi over 2. So what we actually want to do here, and this is the tricky part, is you want to kind of fold it into thirds. So you kind of make a little s out of it. And then if you can kind of get it so that it lines up and kind of folds flat with that S shape. So you get kind of like a S or a Z when we fold it. That has now done a third from the half. So a third of a half is a sixth. So we've now added those sixth lines. Now, those sixth lines effectively will also give us the thirds, because 2/6 is 1/3. So this is now going to be all the lines which we need. So we can actually, if we want, go in here and clean up these lines a little bit so make them a little bit more visible, because it's hard to see folds when you're just looking at my through my document camera here. So here's my 0 or my 2 pi. Here's my pi. Here's my pi over 2. Here's 3 pi over 2. So I'm kind of labeling those as we go here. Then I had my fourths. So this is going to be pi over 4, 2 pi over 4, or 1/2. This is 3 pi over 4, 4 pi over 4, or 1, 5 pi over 4, 6 pi over 4 is 3/2, and then 7 pi over 4. That angle there. And then I have all of my sixths that I need to add in here. And mine didn't fold perfectly, so I'm just going to kind of put it as close as I can get it. And there's going to be 2 over here. Okay, so let's try and label those. So then I here first have my 1/6, or pi over 6, I should say. And then this one would be 2 pi over 6, or 1/3, so pi over 3. So 2 pi over 6, 3 pi over 6 is going to be back up to 1/2. 4 pi over 6 is going to be 2 pi over 3. And then 5 pi over 6. 6 pi over 6 is back to 1 full pi, and then we're down to 7 pi over 6. 8 pi over 6 is going to reduce to 4 pi over 3. 9 pi over 6 is going to reduce to 3/2, and then 10 pi over 6 is going to reduce to 5 pi over 3. And then lastly, we're going to get down to 11 pi over 6 for that final angle. And those are all of the angles that we were kind of asked to get. Now these are the kind of main angles we're going to be encountering. Now, currently, our circle is probably a little bit ugly, but you have a good idea of kind of where things are at and kind of what some general fractions are. Now I'm going to kind of make my starting point a little bit bolder. I'm going to kind of go over it with like red. You can highlight it, whatever. I was just going to, hey, I start here and then here's where all of my angles are. This makes it a little bit faster when I need to actually go and use it. So let's start to use it now. So I hop back over here. I'm going to be asked a series of kind of questions here. So we notice that a bunch of these angles, they either end or have fractions of over 2, over 4, over 3, over 6, or they're nice pretty whole numbers. So all of my whole numbers, which would be 0 pi, 1 pi, and 2 pi, they're all on this x-axis, right? So that's the commonality there. Now how about every angle that is over 2? Where are all of those at? Well, those are only like a little bit too close. Now we can see all of it. Okay. So ones that are over 2 are top and bottom. Okay. Now how about ones that are over 4? Well, it happens here, and here, and here, and here. So they're happening at those corners. Notice how they're vertical from each other. How about over 3s? Well, those are happening here and here, here and here. So again, they're vertical to each other. And then the over 6s, here and here and here and here. Again, they're vertical to each other. That is not by coincidence. That is going to happen no matter what fraction you end up using here. So hopping back here, let's take this a step further. Okay, so let's talk about the term coterminal. So coterminal means it terminates at the same spot. So if I think about my angles and where they quote unquote terminate, they always start here on that kind of red line that I kind of drew in, right? So the angle pi over 6 terminates here. So this is its terminal ray or its terminal edge here. So it goes from here to here. It terminates at this point, right? The angle pi over 3 terminates here. Okay. So when I say coterminal, it means, hey, it's another angle that terminates at the same thing. Co as in cooperate or working together, right? It terminates at the same place as another angle. So it's going to ask us, hey, what angle is coterminal? So say 5 pi over 6 is coterminal with negative 7 pi over 6. Now, we haven't really dealt with these negative angles yet, but let's think about it. Well, if the positive angle is going in this direction, the counterclockwise direction, a negative angle will just go in the clockwise direction from the same starting point. I go clockwise. Okay. So negative 7 pi over 6, well, 7 pi over 6 is that far, right? It's a half circle and then one more sixth step, right? So if I do negative 7 pi over 6, well, that's a half circle in this direction and then one more sixth step from that. So that negative 7 pi over 6 would be coterminal with 5 pi over 6. They're coterminal, they both stop at the same place. So every one of these angles has a coterminal angle that's just negative and going the other way. So for example, 11 pi over 6, I could get there by going 11 pi over 6 in this positive direction, but how could I get there going the negative direction? Well, it's just this far, which is a distance of pi over 6, so it's negative pi over 6 would be coterminal with 11 pi over 6. So knowing that, go ahead and pause the video and try and answer problems 120 and 121. And then I'll be back here when you're done. All right, so let's take a look at the first ones here on 120. So we're going to be trying to find ones that match up with negative 2 pi over 3. So 2 pi over 3 is this distance here, so it's a quarter, and then that extra sixth. So going in the negative direction, it's a quarter, and then an extra sixth, so it's going to be 4 pi over 3 as its coterminal angle. And then how about 5 pi over 4? Well, 5 pi over 4 in the positive direction is here. So that's a full half and then an extra fourth, right? So I'm going to do that in the opposite direction. Full half and then a fourth. It's going to be 3 pi over 4 is coterminal with negative 5 pi over 4. And then we have negative 11 pi over 6. So 11 pi over 6 is all the way but 1/6 off. So if I go the opposite way with negative 11 pi over 6, it's the whole thing within 1/6 back. Hey, I'm coterminal with pi over 6. All right, and then number 121 is asking how about angles that go beyond 2 pi, right? So if I have 10 pi over 3, okay, that's more than one full circle. So one full circle is 2 pi, but how many thirds is 2? 2 is 6 thirds. So 6 pi over 3 is one full circle. So I've gone 6 pi over 3. I'm going to have 4 pi over 3 left over from my 10. So I go over to 4 pi over 3. There I am, right? Then the next one, 17 pi over 4. Well, fourths, it takes 8 pi to get one full circle out of fourths. So 8 pi over 4, I'm here. For 17, I can go again. That gets me to 16 pi over 4. And I still have 1 pi over 4 left to go. So I end up here at pi over 4. Okay. Then, how about negative 25 pi over 6? And if you can do this one, you're good, right? So sixths, it's going to take 12 sixths in order to get one full circle. So I'm going in the negative direction. So here's negative 12 sixths. And I need to go negative 12 sixths more. That gives me to negative 24 sixths. And I still have one negative sixth left to go. So it's going to take me down to 11 pi over 6. Right. So there we go. There's another coterminal angle with it. Now, when we're asking for coterminal angles, we're typically going to be asking for ones that are kind of in this kind of positive unit circle. But if you just need any of them, you can find any by going more and more pi's, 2 pi's forward or backward, and you'll get any number of coterminal angles with these. All right, with that, we got a little bit of notes here. So these just depend on what a rating is. Again, read through that. If there's stuff there you feel like you need to write it down for your own use in your notes, then go ahead and do so. Otherwise, just kind of make sure you understand what it is saying there. All right, and then for our closure, just kind of in your head sketch a circle that and an angle that is this many radians. So think about it in terms of kind of estimating, right? So 7 pi over 6, well, one full pi is a half circle, so it's then a sixth more than that. So it's a half circle and a bit more, right? That's what we want as far as kind of estimating it goes, right? Negative pi over 2, well, pi over 2 is that 90-degree angle, so it's kind of 90 degrees down. And then 11 pi over 4, well, 8 pi over 4 would be one full circle. So then we're going to have that, and then 3 pi over 4 more, which is going to be halfway between a 90-degree and a 180-degree angle. So whatever strategies you can kind of use to get a good estimate, at right now, if you can kind of estimate it, then we are good. But eventually, I want us to be fairly comfortable with kind of calculating what those would actually be, like we did here. All right, with that, here is our homework. We're doing 122 through 128, and I will talk to you guys next time.